Okay, I'm here, now I'm tuned in on 40 meters and listening to some CW signals. That's with the CW filter not in. You can see the S meter action. When I put on the narrower filter, I usually have to touch up the tuning just a little bit. So you can turn up the volume and not have to listen to a lot of noise. I might be able to make this a little... There it is. So this is also working very well. Had a little bug with this DFD2 readout where it was not calculating the end frequency correctly for 40 and 80. And I got lucky and found that I could change his option switches on the back of the DFD2 and therefore rigged up this switch over here, which gives me the correct readout in the 80-40 position by changing the options. It's not supposed to be necessary, but I probably got an earlier version of his chip that had a bug in it about that. Now as long as I've got the cover off, which is why I started this, this is what it looks like for the top part inside. This is that NESCAF audio filter I was talking about. The box in the center is the BFO. Over here is the S meter driver that I built on a perf board, no PC board, Manhattan construction style. That's the driver that I got off of Wes's website. The board behind it over here is I believe that's the first mixer. And these are 1, 2, 3, 4. This is 40, 30, 20, 15, and 10. Those are the band filter boards. Below it, just on this side, I'll have to show you this in another video, turn the thing over. I have the oscillators for each of these bands. And below and in front here, of course, the band switch. That's all beneath the chassis. Over here, we have the product detector with its mixer and the integrated with the audio amplifier. On the back here is a DC regulator. I can read the voltage by pushing the button on that. I can read the voltage coming in from the power supply, which is this Astron supply that I'm using now. That feeds 13.8 in, and I've got it reduced down to 12.0, feeding the circuits in the radio. We had a little bit of a problem with voltage sensitivity when at 12 volts in the IF board and also in the AF board. So in the AF board, I reduced the voltage by adding a resistor down here to the feed that would normally have 12 volts going into the AF board. And I did something similar on the IF board, which I'll show you in my next video. Wes suggested that I feed the output transistors with 6 volts regulated, so I did a setup for that. And I also fed the other transistors on the IF board through a reducing resistor, because I found that both the IF board and this product detector AF board were a little sensitive to 12 volts, and they worked a lot better around 11 volts. I don't know why, but made a big difference. And actually, I'm running this AF board at about 10.6 volts now, and it got rid of some of the distortion I had been experiencing on SSB signals. On the back here is what's the name of it? Hi Let Go. It's a company that, one of those Chinese companies that make lots of different assemblies. This is an audio amplifier that I got for like $12 on Amazon. So, and that's it. They came with a potentiometer on the board. I took that off and rewired it to this one so I can control the speaker volume as needed depending on the speaker from the outside of the chassis. So, next video I'll show you what the bottom looks like.